all of these concepts well, you should be able to do all the questions from that. And if you have any questions, you can let me know in the next class then. The remaining 20-25 minutes I'm going to spend on covering another relatively small topic, which is shading inequalities. Okay. Now, before that, we need to do something small that we can cover right now here as well. That is drawing straight lines. Okay, that's a small thing that you should know here. Before we talk about shading inequalities, drawing straight lines, drawing graphs of straight lines. Graphs of straight lines. So if you have any straight line, for example, if you have x plus 2y equal to 4, and what you want to do is you want to write down the equation, you want to draw the graph of this function. How would you do that? Since it's a straight line, all we need is any 2 points on the line. So what we do is we draw x and y axis like this. We have this y axis, we have this x axis. You can put any value of x in this and get a corresponding value for y. So for instance, you can input x equal to 0. You can make a table like this such that you have x coordinates in the first line, y coordinates in the second line. All you have to do is put a random value of x in this. Let's say we input 0. When we input x equal to 0, we get y equal to 2, right? So when x equals 0, y equals 2. That is one point that we have lies on this line. We can mark that point here. Let's say this is 0, this is 1, this is 2, and then this is 1, this is 2, this is 3. If we had to draw this line, we would need just 2 points. Let's mark that point 0, 2. That will be here. This is 1 point. When you're drawing graphs, generally Cambridge prefers that you draw crosses like this. Okay. Draw a cross, small cross like this, such that the point that you're marking, that is the point of intersection of these two lines that you mark there. You draw a small cross like this. Okay. Do not draw it very big, but a small cross like this. Okay, so that's 1 point. Take any other value of x, any random value of x, or you can also do it like this, that you find you since you already have the y-intercept, now you can find the x-intercept as well. How do you find x-intercept? X-intercept is when y is equal to 0. So you can, the other point that you take could be when y is equal to 0. When y is equal to 0, you get x equal to 4. That's another point. You can mark that point on this diagram. And that is right here. So we have marked these 2 points. All you have to do now is join these 2 points with a straight line. And that's it. Okay. And that will be the graph of the straight line. So if you have any straight line that you have to draw, all you have to do is take 2 points on the line. You can take any 2 random points, input any value of x, get the corresponding value of y from that, plot that point, take another random value of x, get the corresponding value of y, making sure, of course, these are reasonably small numbers so that you can actually draw on the graph that you have. Once you have those 2 points, just join those 2 points with a straight line and extend on both sides, extend on the left side, extend on the right side, and that should be the equation of the line that you want to draw. The graph of the line that you want to draw. Or if you don't want to take random points, another idea is that you find the x-intercept and the y-intercept. So you put x equal to 0, you'll get a corresponding value of y from that. You put y equal to 0, you'll get a corresponding value of x from that. Take those 2 points and then join them. You'll get a straight line. Now, sometimes we say that instead of taking 2 points, you can take 3 points as well, just to make sure that you are not doing any careless errors. Because if all 3 of those points that you have taken, they lie on a straight line, that will kind of confirm that your working is correct. Otherwise, it is possible that if you just take 2 points, if one of them is incorrect, then you might run into problems because your line would be incorrect. Taking 3 points ensures that you are not doing any careless errors. But if both of the points that you're taking are correct and you're sure about that, then 2 is going to be enough You just mark those 2 points and draw that line. It would look something like this. Okay, so that's how we draw straight lines. Take 2 points and just draw them. When we have x equal to something, remember that's a vertical line. When we have y equal to something, that's a horizontal line. Okay, now keeping that in mind, you sometimes have to shade regions on a graph based on some inequalities that they give. Okay, now it's a small concept. Let's discuss this next. Shading inequalities. And it would be linear inequalities. Linear means that the power on x and y, that they're going to be 1. Okay, we won't be having power 2 or 3 here. It'll just be 1. Let's understand what this is about using this example. So I've taken this from a past paper. It says, shade and label the region are defined by these 4 inequalities. Okay, now that we understand how to draw equations, how to draw straight lines, how to draw graphs of straight lines, let's use that to answer this question where they want us to shade the region defined by these inequalities. Now, whatever you're given, the first thing you would have to do would be, whatever inequalities you have, you first of all treat them as equations. You say x is greater than or equal to -1. You replace inequalities with equations. So you say this is x equal to 1. You say this is y equal to 4. This is x plus y equal to 6. And this is y equal to x. Okay, so rather than thinking of inequalities, first of all, you think of equations and just draw those straight lines, first of all. Okay, so we'll come to inequalities, but for now, what we have to do first is just draw these equations, first of all. Okay, draw the graphs of these equations. X equals 1. What does that graph look like? X equals 1, remember, x equals a constant. What type of lines were they? They were vertical lines, right? X equals 1 is supposed to be a vertical line. Where would that be? Where the x coordinate is 1, the line would look like this. When x is 1, you draw a vertical line like this. When x equals 1. Okay. Let's label this line. This is x equals 1 line. All right. Okay. Now, the second line that we have to draw is, again, the inequality says y is less than or equal to 4. What we do is, we first of all draw the line y equal to 4. Now, what is this line? Y equal to some constant. This is going to be a horizontal line. Okay, so this line is a horizontal line like this when y is equal to 4. So this is a horizontal line when y equals 4. Let's draw that line as well. It would look like this. This is y equal to 4. Okay, so that's the second line that we have drawn. Now the third line is x plus y equal to 6. Now this is not horizontal or vertical. What do we do for this line? We can take any 2 points on the line. Let me write that on the side, x plus y equal to 6. Let's take 2 points on the line. For instance, we can put some values of x and get corresponding values of y. If x is 0, what's the value of y? Y is 6, right? And if y is 0, what's the value of x? That is 6. Let's mark these 2 points, 0, 6, and 6, 0. 0, 6 is going to be this point here. And 6, 0 is this point here. You have these 2 points, just join them, and that will be this third line, x plus y equal to 6. Let's write that down. This is x plus y equal to 6. That's the third line that we have drawn here. Then the fourth one, y equals x. What kind of line is that? Y equal to x. All the coordinates here are going to be equal. So if you have x equal to 0, y is 0, x equals 6, y is 6. Mark any 2 points, let's say 0, 0 here and 6, 6 here. And this line is going to look like this. This is the last line, y equal to 6. So first of all, you draw all of these lines. Okay, think of these as equation first of all, and draw those equations. Now you need to decide which sides of these lines you are going to be shading. Is it going to be the part that is above the line, above a particular line? Is it going to be a part that is below a particular line? Is it going to be to the left side or to the right side? Now, how do we decide that? In order to decide which side of the line to shade, you would always write the inequality in this form, first of all. Y greater than something or y less than something. Okay. First of all, you will make y the subject. Take everything to the other side, make y the subject. So let me write that down here. The first thing you would do would be make y the subject in all equations, in all inequalities. So in all of the inequalities, I'll talk about the exception there in a moment, because there's one inequality that does not have a y in it. We'll talk about that. But in general, for all inequalities that have a y in them, we make y the subject. That means we bring y to the left side, take everything else to the right side. And then if you have y greater than something, or if you have y greater than or equal to something, what you do is you shade the part above the line. Shade the region above that line. So when you have greater than or greater than equal to signs, you shade the part that is above the line. Okay. And if you have less than or equal to less than something or less than or equal to something, in this case, what you do is you shade the region below the line. Okay. When you have greater than something or greater than equal to something, you shade the region above the line in case of these signs. And when it is less than something, less than equal to something, you shade the region below that line. Okay. There is an exception, and that exception is when you don't have a y there. Okay. When there's no y, what do you do in that case? In that case, you would have x greater than something or x greater than or equal to something. Or you would have x less than something or x less than or equal to something. In these cases, when there is no y in the equation, and it's only in terms of x, basically it's going to be x equal to some constant. What do you do in this case? When it's greater than sign, greater than equal to sign, you shade the right side. You shade the right side in this case. And when you have less than sign or the less than equal to sign, you shade the left side. Okay. In most inequalities, you would make y the subject. If it's a greater than sign or greater than equal to sign, you would shade the region above the line. If it's a less than sign, you shade the region below the line. In some rare cases, there would be no y in the inequality. In that case, you shade the right side when it's a greater than sign, and you shade the left side when it's a less than sign. Okay. Now, let's go back here. We have drawn these lines. Okay. X greater than or equal to 1. Let's start with that one first. Greater than or equal to. X greater than equal to. There's no y here. What does greater than mean? That means we have to shade the right side of this line. So the x equals 1 line, we shade the right side of that. Let's just mark it here for now. We have to be on the right side of this. Okay. Don't shade yet because the region that you shade has to satisfy all the inequalities, right? For now, we have just figured out the region with respect to x equals 1 line. That means x greater than equal to 1 inequality. We also have to think of the remaining inequalities first of all. The second one is y less than or equal to 4. Now, in this case, you do have a y and it already is the subject. What does that mean? Less than or equal to, that means we have to shade the region that is below this line. So below the line, y equal to 4. So we have to be below this line. Okay, so we have to be to the right of x equals 1 and below y equal to 4. Okay, these are two conditions that we have. Now, let me just erase the part that is not valid anymore. So we can't be above the line y equal to 4, right? So we can't be here. We can't be to the left as well. So these are the regions that are possible. Below y equal to 4 and to the right of x equals 1. Okay, let's think of this third inequality now. Now, in this case, y is not the subject yet. So first of all, you have to make y the subject, making sure it's still positive. X plus y is less than or equal to 6. You can write this as y less than or equal to 6 minus x. There's still a less than sign there. What that means is you have to shade the region to the left, shade the region below this inequality as well, because there's a less than sign. X plus y equal to 6. Which equation is that? That's this equation. Which region do we have to shade in this case? Below this line. So we have to be below this line as well. That's another condition. Below the audience line. And then finally, this is the last inequality that we have. Y greater than or equal to x. We already have y the subject here. Greater than means we have to shade the region above this line. So we have to be above this line. Now, which region satisfies all of these conditions? Which region are all of these arrows pointing towards? It's the region in the middle there. We will shade that region now and label that region R. This is the region that satisfies all of those conditions. They want us to label this region as well. The region is going to be labeled R, and that is our final result. So we draw all of those lines, make y the subject where we can make them one, make it the subject. If it's a greater than sign, we shade the region above. If it's a less than sign, we shade the region below. If it's x greater than something or less than something, in that case, we shade the region right in case of greater than sign, and shade the region to the left when it's a less than or less than equal to sign. Okay. Now there's a small variation here. Instead of greater than or equal to, they could say x greater than 1 without the equal to sign. That would mean that you're not going to include the points on that line. So for instance, in this case, it was greater than or equal to. That means you can be on this line x equal to 1 as well. So points on this line also satisfy the condition because there's an equal to sign there as well. But if it was just greater than 1 without the equal to sign, that would mean the points on the line x equals 1 would not be considered. And in order to show that, you would make that line dotted. So if it was a greater than 1 inequality, you would draw that like this. You would say it's a dotted line like this because that would show that the points on this line are not going to be included. Okay. It's still going to be the right side of that line, but if the equality sign is not included, we draw it a dotted line instead of a solid line. In this case, since all of these inequalities had an equal to sign with them, we drew all of them as solid lines. Okay, but let's take another example. Here, they have given us a graph like this, and they want us to write down the inequalities ourselves. Okay, so now we need to write down the inequalities. that represent this shaded region R. And you see the lines that they are drawn, they are dotted or dashed lines like this, which means that we are not going to have equal to signs here. It'll just be greater than or less than. Okay. Now, how do you approach problems like these in which you have to do the other way around now? In the previous example, they gave us the inequalities and we had to show that shaded region. But now they have shown us the shaded region and we want to write down the inequalities ourselves. Okay, now how does this work? Let's think about it. It says the shaded region are contained inside the dotted boundary lines. Now you see made this word bold inside the dotted boundary lines. That means the points on these lines are not included. Okay, it's only the region inside these lines. Okay, it's defined by three inequalities. So one of these these inequalities is x greater than 2. Write down the two other inequalities. Now, x greater than 2, that equation would be x equal to 2. What kind of equation, what kind of line is that? That's a vertical line. So basically, x equal to 2, this line, they've already given the equation of this line. Okay, so this vertical line is already given. The inequality corresponding to that, they've told us that that's x greater than 2. We have to be above this line. Okay. Now, first of all, we want to write down the equations of the other two lines that we have. And then we'll think how to write down the inequality after that. What are the other two lines? One of those lines is this horizontal line. How do we write equations of horizontal lines? Equations of horizontal lines are y equal to some constant, right? Y equal to some constant. What constant is that? In this case, that's 12. So we can say the equation of this horizontal line, therefore, is y equal to 12. Okay. Now, that's the equation of this line. Is the region R below this line or above this line? It's below this line. So what is the inequality going to be? We say the inequality is y less than 2. That's your first less than 12, sorry. Y less than 12. We have to be below that line, right? So we use the less than sign there without the equal to, because they're dotted lines, right? The points on the lines are not included. That's why less than 12. Okay, what about the other line now? This is the other line that we have. We have to find the equation of this line. How do we do that? How do we find the equation of any line? We need two things for that. We need the gradient and a point. Do we have a point on the line? Well, we have many points on the line. We can use any of them. The easiest point to use could be this point 0. That's essentially the y-intercept of this line as well. The y-intercept is 0. So you can use the y equals mx plus c form for this, right? Because the y-intercept is known. We know the y-intercept is 0. So this is supposed to be 0. What about the gradient? We can take any 2 points on this line to find the gradient. Generally, when we draw lines ourselves, we prefer taking points that are further apart from each other so that the gradient that we get is more accurate. In this case, they have already given us the line themselves, which is fairly accurate. It is okay to take the points anywhere, but the general rule is that you should take points that are a bit far away from each other. That improves your accuracy, especially when you do graphs of functions later on. When you draw tangents, on the tangent, you should take points that are away from each other, that are far away from each other. That improves the accuracy. In this case, for example, if we take 0, 0 as 1 point, we could take another point on the other side. Let's take this point. This point is 7 and 14. How do you find the gradient now? Gradient is y2 minus y1, so that's 14 minus 0 over x2 minus x1, that's 7 minus 0. The gradient of this line is 2. That means the equation becomes y equals 2x plus 0, which is y equals 2x. So this equation is y equals 2x. Now, do we have to be above this line or below this line? We have to be above this line. So which inequality sign do we use then? we say this should be y greater than 2x, and that's the second inequality that we had to write there. Okay, so these are the two inequalities that they wanted us to write down. We first of all found the two equations, y equals 12. Since we have to be below that, we say y is less than 12. We found the other equation, y equals 2x. We have to be above that line. So we say we have y greater than 2x. That's the second inequality. All right, that was the first part. Now let's look at the second part as well. Now they're saying the points C and D. The points CD, where C and D are integers, lie in the shaded region R. Find the maximum value of C plus D. Okay, so we need to find the maximum value of C and D. Now, which points lie in the shaded region? Remember, we cannot consider points on the lines themselves because these are strict inequalities without the equal to sign. So these points cannot be considered. Okay. So the only possible points satisfying this condition where both the coordinates C and D are integers, where are they going to be? Let's mark them. Notice the axes first of all. On the horizontal axis, the x coordinates inside the region could be 3, 4, and possibly 5. Because 6 is on the boundary, we cannot consider that. 2 is also on the boundary, we cannot consider that. So inside the region, we can only have 3 possible x coordinates, 3, 4, and 5. Vertically, notice the scale. We also have 5 here, we've got 7 here, we've got 9 here, and 11 here. So the points inside the region could be all of these points. All of them have integer coordinates, right? So I'm just marking all of them. These are all the possible points, the red points inside the region that have integer coordinates, right? The x coordinate of all of these points. Okay, I'm sorry. So these are not possible. Only these. So with 3 as the x coordinate, the y coordinate could be 7, 8, 9, 10, 11. Okay. And with 4 as the x coordinate, the y coordinate could be 9, 10, 11. And with 5 as the x coordinate, the y coordinate could only be 11. These are all the possible points inside that region that have both their x and y coordinates integers. What we need to do is we need to find the maximum possible value of C plus D. What's the maximum possible value of C? The x coordinate, that is 5. What's the maximum possible value of D, the y coordinate? That's 11. So what about C plus D? That will be 5 plus 11, and that gives us 16. This is the maximum possible value of C plus D in this case. Okay, so basically, if we want to maximize the x coordinate, we want to go as far to the right as possible. If you want to maximize the y coordinate, we want to go as far above as possible. This is the point that has the maximum x coordinate and the maximum y coordinate inside this region. Okay. Now the second part says, find the value of D given that D is equal to 3 times C. D is equal to 3C. What that means is, remember D is the y coordinate, C is the x coordinate. We want to find a point where the y coordinate, remember D represents the y coordinate, is 3 times the x coordinate. Okay, where the y coordinate is 3 times the x coordinate. For instance, if the x coordinate is 3, the y coordinate should be 9. Is that possible here? Yes, this point satisfies that condition. But is there any other point line like this? Let's check for that. If the x coordinate is 4, the y coordinate would have to be 12. Can we have that point? No, that's outside the region. If the x coordinate was 5, the y coordinate would have to be 15. That's also outside the region. So the only possibility for this condition to be met, where the y coordinate is 3 times the x coordinate, that would be if the x coordinate is 3 and the y coordinate is 9, and that will be this point here, 3, 9. What are they asking for? Value of d, value of the y coordinate. If the point is 3 and 9, the y coordinate would be 9. So we say d is equal to 9. That is the only possibility inside this region where the y coordinate is 3 times the x coordinate. Okay, that's the last part of this question, B2, and that's your final answer. That's how you approach questions like these, where we have to write down the inequality given some shaded region, or where we have to shade some region given some inequalities. Okay. And again, I'll be uploading a worksheet for this as well, for shading inequalities. Please attempt questions from that. Take this weekend now to complete all the assigned worksheets, so that if there are any problems anywhere, you can let me know about them. That's it for today. We'll stop here, and I'll see you again in the next class. If you have any quick questions, you can let me know. Otherwise, we end this here. Any questions, anyone? Any problems? No? All right, good. So I'll see you again in the next class then. Please make sure to complete the worksheets and let me know if there are any problems. And now we are gradually going to start moving on to the relatively more difficult topics. Until now, it was relatively straightforward. There are still some smaller topics left, like significant figures, standard form. We'll do them at a later point, all of them together. But now I want to gradually move on to the relatively bigger topics, which are tested more in the calculator paper. So we'll gradually pick up speed as well now. Make sure that you're practicing alongside so that you don't have to keep catching up later on. All right, that's it for today. I'll see you again in the next class. That's on Monday. Please take this time to do a lot of practice and let me know if there are any problems later on. All right. Okay, I'll see you again in the next class then. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.